Today, the world faces severe energy challenges. Over-reliance on fossil fuels like coal and oil has caused energy shortages, rising prices, and serious environmental problems such as global warming and air pollution. What's worse, fossil fuels are non-renewable and will run out sooner or later, so we urgently need clean alternatives. Energy storage emerging technologies play a vital role in the energy transition. This is store surplus solar and wind power, stabilize power supply, and solve intermittent problems of renewable energy. These advanced technologies greatly promote clean energy popularization and accelerate traditional energy replacement. Solar and wind energy are the most promising solutions. As renewable resources, they produce no harmful emissions during use, effectively cutting carbon footprints and slowing climate change. Solar power can be widely used through photovoltaic panels, supplying electricity to homes and industries even in remote areas. Wind energy, generated by wind turbines, provides stable, large-scale power for national grids. Both energy sources are sustainable and cost-effective. They can ease energy crises, reduce environmental damage, and build a low-carbon, sustainable energy future for the world. So, what can solar and wind energy be used for exactly? The applications are very broad. In terms of solar energy, the most common use is photovoltaic power generation, from large desert power stations to the PV panels on our own rooftops, all providing electricity for us. In addition, solar water heaters have long entered thousands of households. Wind energy is mainly used for power generation. Whether it is windmills on vast plains or huge offshore wind turbines, all are continuously converting wind energy into electricity. More importantly, they bring huge benefits. Environmentally, they do not burn coal or oil, directly reducing greenhouse gas and pollutant emissions, which is crucial for mitigating climate change and improving our air quality. At the same time, they are also very water saving. Socially, developing these indigenous energy sources helps safeguard national energy security, create a large number of jobs, and promote green economic development. Of course, everything has two sides. Solar and wind energy also face some practical challenges. First, their output is unstable. Solar power doesn't generate electricity at night, and wind power fluctuates, posing great challenges to the stable operation of the power grid. Second, their energy density is relatively low, requiring large land areas to generate sufficient electricity, which is a problem in land-scarce regions. In addition, although generation costs are falling, initial construction investments remain high. We also need to pay attention to potential ecological impacts, such as the impact of wind power on birds and the environmental issues in PV panel production. Finally, effectively integrating this unstable power into the grid and solving the dependence on weather issue through energy storage technology are urgent technical challenges to overcome.
Next, I'd like to talk about how secondary batteries help solve the instability problem of renewable energy sources. First, let's take a quick look at the main type of secondary batteries. There are four important ones: lithium-ion batteries, lead-acid batteries, solid-state batteries, and sodium-ion batteries. Lithium-ion batteries are currently the most widely used. They have high energy density and a long lifespan, which make them very popular. Lead-acid batteries are much cheaper to produce, but their energy density is quite low. Solid-state batteries are still in the testing phase, but their promise much higher safety and energy density. Solid-ion batteries have lower energy density, but sodium is very abundant and cheap, so they are especially suitable for large-scale energy storage. Now let's talk about how secondary batteries actually work. At their core, Charging and discharging are chemical reactions. When the battery is discharging, lithium ion move from the negative electrode through a special membrane to the positive electrode. At the same time, electron flow through the external circuit, creating an electric current that power our device. When charging, an external power source apply voltage, forcing the lithium ion to move back from the positive electrode to the negative electrode. So, how actually do these batteries help solve the instability of renewable energy? Secondary batteries mainly act as a stabilizer and solve the following three problems. First, time shifting. Solar power generation peak at noon, but the peak electricity demand in cities is in the evening. Second, frequency regulation. These two renewable energy sources are very strongly affected by the environment. Even a small change can cause a sharp fluctuation in power generation. Finally, peak shaving. Sometimes the power grid experiences a sudden surge in electricity demand. Building more generator for this is very unfriendly to the environment and require a lot of cost. The characteristics of secondary batteries are perfectly suited to solve this problem. Their ability to store electrical energy allows them to store excess power and release it when demand is high, while maintaining the stable operation of the power grid. They effectively reduce the reliance on fossil fuel power plants during peak electricity usage period. Moreover, their extremely fast response speed can instantly absorb or compensate for energy, making the power supply more stable. Next, my teammate will talk about the current limitation of secondary batteries.
Good morning, everyone. Today, I will talk about two parts of my presentation. First, I will talk about the problems of the lithium-ion batteries. First, viscous scarcity and G-rest. Lithium-ion batteries need many important metals: lithium, cobalt, and nickel. We depend too much on these metals. The supply chain is fetch. Sometimes the prices change a lot. This makes the cost not stable. Second, cost pressure and economic. The cost of raw materials is very high. Lithium and cobalt take more than 50% of the total cost. Recycling is also expensive because of the environment and transport costs. Third, safety risk. Lithium-ion batteries have flammable liquids inside. If they are overcharged or short-circuitable, they can catch fire or even explode. When we take apart all batteries, they are also dangerous. Fourth, environmental impacts and recycling. Making metals needs a lot of energy and great pollution. Current recycling technology is not good enough. Some methods waste water, some cannot get back enough lithium. 5. lifespans and performance. Batteries are retired when their capacity is below 18%. Different batteries have different health conditions. This makes them hard to replace. These are the main limitations of today's lithium-ion batteries. Now let's move to the second part, solution and future development. First, we can develop new batteries. We have two good choices, solid-state batteries and sodium-ion batteries. They are safer, cheaper, and hold more power. Second, we can improve BMS. BMS is the battery's brain. We can use AI to check battery health and find problems early. Third, we need better cycling systems. Government and companies work together to recycle batteries cleanly. Fourth, we can reuse all batteries. All batteries can be used for power, storage, and slow cut. In short, lithium-ion batteries have some problems, but new technology can solve them. New battery smart management, recycling, and reusing will make energy storage cleaner and safer. That's all. Thank you for your listening.